Hi viewers, welcome to today's tutorial. Today's tutorial will be treating a question on the capacitance of a capacitor. The question says the total capacitance of the circuit below is, you have this arrangement, you have this parallel arrangement here in connection with this capacitor here, and we have the options 0.25 millifarad, 1.50 millifarad, 0.75 millifarad and 1.25 millifarad. We have the first capacitor here to be 2 millifarad and others are also 2 millifarad. So how are we going to solve this solution? We firstly resolve the capacitance in parallel, and when capacitors are arranged in parallel, what you do to find the resultant capacitance is add the capacitances together. So to resolve this, let's pick the capacitors in parallel. 1, 2, okay, let me name it. Let's say this is C1, this is C2, C3 and C4. So I can now say the resultant of C2, C3, C4 would be C2 plus C3 plus C4. So I'll just add everything together and I'm going to have 2 millifarad plus 2 millifarad plus 2 millifarad, which eventually should give me 6 millifarad. So I'm done finding the resultant of the 3 capacitors in parallel. So their resultant capacitance is 6 millifarad. So how do I combine that with the 2 millifarad here? To find the resultant capacitance of capacitors arranged in series, we are going to have this, we are going to use this formula, and let me just bring a circuit diagram of what I'm just saying. So we have this now 2 millifarad connected in series with 6 millifarad. This is the C1 and this is the resultant of these 3 connected in parallel. So at this point we cannot find the resultant of this using the formula here. We have 1 over resultant capacitance. 2 millifarad means 2 times 10 raised to power minus 3 plus 1 over 6 millifarad, 6 times 10 raised to power minus 3. So the LCM here is 6 times 10 raised to power minus 3. 2 times 10 raised to power minus 3 is 6 times 10 raised to power minus 3 is 3. So 3 times 1 will give you 3 plus 6 times 10 raised to power minus 3 is 6 times 10 raised to power minus 3. You have 1 times 1, and I'll have 4 over 6 times 10 raised to power minus 3. And from this point I can decide to inverse. So whatever I do to the first, to the left hand side, I have to do it to the right hand side. So what I'll do is I'll find the reciprocal of 1 over CT and reciprocal of 4 over 6 times 10 raised to power minus 3. And that means I should inverse that. And this will turn to 6 times 10 raised to power minus 3 over 4. 2 here, 2 here, 3. And this is going to give us 1.5 times 10 raised to power minus 3. And I can express myself in this way, 1.5 milli, since I know this is millifarad. So 1.5 millifarad will be the total capacitance in this circuit. Thank you for watching the video.